All right, so today we are working on 7.3, which is on dividing radical expressions. So the rule here is kind of like with multiplication. If you've got your nth root of a divided by your nth root of b, what you can do is you can put it together. You can do a divided by b and then take your nth root. So in other words here, if I had the, let's put a number up here. Let's put the third root, or yeah, let's do third root of 27 divided by the third root here of 8. So if you wanted to, you could put this together and say the third root of 27 eighths. Or we could do the other way around. If we had the third root of 27 eighths, we could split it apart and say the third root of 27 divided by the third root of 8. In this case, it's better to have it this way and then figure it out. The third root of 27 there is 3. The third root of 8 there is 2. So you just get 3 halves. Sometimes, however, in here you want to be able to reduce that fraction down first, or do the division there first, and then take the third root. In this case, it doesn't end up being very nice to do it that way. For instance, this next one here, you've got the square root. So if I put it together, I would do 18x to the fifth divided by 2x to the third. So you want to do your division here in this case first. So let's do our division here first. I'm going to move this 3 halves out of the way. So if I do my division here first, 18 divided by 2 here is 9. X to the fifth divided by x to the third. If you remember how that goes, it goes 5 minus 3. And since the higher number at the top, it's going to stay at the top. I don't have to put this over 1, but I could. Square root of, so square root of 9 there, if you want, you could either find that. Square root of 9, hopefully you know that to be 3. And then underneath the square root, there we have 5 minus 3 there, which is 2. And then we got the square root of x squared. And if you don't know, you can just pull it apart. Remember, this is like a little 2 out there. Since there's a pairing there, it ends up being 3x. And so we can come down here to letter B. We can do the same thing if we want. We can do the division here first, and then do the square root there last. So dividing this out, 50 divided by 2 there is 25. The bigger number is at the top, so I'm going to put it at the top. X is 6 divided by x to the fourth. I can subtract those powers. I'll write it out there for you. So we end up there with 6 minus 4, there is 2. So now I can think about what's the square root of 25, that's 5. And then if I don't know square root of x there, or square root of x squared, it's the same thing as the square root of x times x, and there's a pairing of those, so it just becomes 5x. So now let's go ahead and let's look at some cube roots here. We could do the same thing. We could put it all underneath the same one, 162 y to the fifth divided by 3y to the second. And we could go ahead and combine these right now. So I could take 162 there, divide by 3, and I'm going to get 54. And then I could take y to the fifth divided by y squared. Remember, that's the same thing as 5 minus 2, which gives us y to the third. And now we're going to find the cube root there of 54. But 54, that's not going to come out nice. So let's break down 54. 27 times 2, because I thought of 2 because it's an even number. I could break down the y's as well if I want. 27 is 9 times 3, and 9 is 3 times 3. So I'll keep writing them out. So 9 is 3 times 3. We're doing cube root here. So again, looking for pairings of 3, because that's what it says out here. And then, so groupings of 3. So grouping there of 3, so I'm going to bring the 3 out. a grouping there of 3y, so bring the y out, and I'm left with the cube root of 2. So we worked with that one. Let's try another one here. We could do the same thing on this one. We could do the cube root there of 81 y to the 6 divided by 3y to the second. Going ahead and see if we can divide this out here. So 81 there divided by 3 looks like 26. No. No, 81 divided by 3 there is 27. So 27. And remember your powers there. Y to the 6 divided by y to the second. You're going to subtract the powers. And we get 4. And it's up to you how you want to do this. You could pull this apart and say what times what gives you 27. Oh yeah, 9 times 3. And then we got 4 y's. 9 there is 3 times 3. Still had the other 3. And then there's 4 y's. Still doing cube root. So looking for groupings of 3. So I've got a grouping there of 3. I'm going to pull it out. Got a grouping there of 3y's. Going to pull it out. I'm left with the cube root of y. So I can't break that down any farther, so I'm finished with that one. And then here's some practice ones. So if you want, you could go ahead and stop the video, try those 2 out on your own, and then we can go through those. All right, so let's go through these. So working through this, I could put it together. Do my division here first. 75 divided by 25, there's 3, and 75 is bigger, so it's going up there. I could subtract x to the 7th divided by x to the 4th, gives me x to the 3rd, because I can take 7 minus 4. And then y to the 2nd still up there. So I end up getting the cube root there of 3x to the 3rd, y to the 2nd. I can't think of any 3 numbers that when I multiply that I end up getting 3, so that can't do anything with the 3 x's and then y's. So looking for groupings of 3. So there's one grouping of 3. So I can pull the x out. And I'm left with the 3rd root of 3, and I'm going to put the y's back together because there's not a grouping of 3 of those either. So I get x times the 3rd root of 3 times y to the 2nd. And then letter F here, I could do the same thing. Put this all together into the square root this time. So 36 divided by 9, there's 4. And then I get x to the 6 minus 4. And 6 minus 4, there's 2. So I get x to the 2nd. So I could either find the square root of 4, which is 2, find the square root of x squared, which is x, and say it's 2x. Or I could break it down. 2 times 2, x times x. Grouping, grouping. I get a group pair there, and I got a pair there. So I end up with 2x. Or some of you, again, like to think square root of 4 is 2, square root of x squared is x, and you'll tell me it's 2x right away. Again, it's up to you how you like to do that. So our next part here, we have to be careful when we're dividing radicals because we cannot leave a radical down in our denominator. So if we want to simplify a radical expression here, we can rewrite it so that there's no radicals up here in the denominator. To do something like that, we can do what's called rationalizing the denominator. What you can do is you can multiply both the numerator and denominator, but what's down your denominator in this underneath the square root. So this is what happens when you've got square roots here. So the square root of 2 times 1, there's a square root of 2. And the square root of 2 times the square root of 2 ends up being the square root of 4, because remember you can multiply those back together. And we know what the square root of 4 there is, it's 2. So now my answer makes perfect sense because I have no radical down or no square root down in the denominator. So we have just done what's called rationalize the denominator by multiplying the numerator and denominator by what's down in the denominator here, so that we can get rid of the square root. So let's come over here and let's work with some square roots here. So we can't leave our answer down there with the square root of 2. So if you can break down what your denominator there is, I would do that, because then you don't have to do so much work at the end. So this one here, I can't break down square root of 2 any farther, so I'm going to multiply my numerator and denominator here by the square root of 2. And I can do that because basically you're just multiplying it by 1, because square root of 2 over the square root of 2 just gives me a value of 1. So up here, I can pull it back together there. Square root of x times the square root of 2 is the square root of 2x. And the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4, we know that to be 2. We can't cross out anything because down the denominator there we have a 2, and up there in the numerator we have a square root of 2, so you can't cross those out. They're not like terms anymore. One's underneath the square root, the other one is not. Let's look at part B. Now part B, I can break down the square root of 8. So I can think of other numbers that go inside 8 besides 8 and 1. I can think in 2 and 4. So I'm going to break down 8 as 2 times 4 times x. Well, I could either just keep going and keep breaking down 8 there, so 2 times, or 4, so 4 there is 2 times 2. So then remember I've got a pairing there, so square root of 5, square root of 2 times square root of 2 there, it's got a pairing, and I'm still left with 2x square root of 2x. We cannot leave a square root of 2x down in our denominator, so we're going to have to multiply the numerator and denominator by the square root of 2x. Putting it back together, since I got a radical at the top, two of those, I can put them back together as 5 times 2x, there's 10x. I'm going to leave the 2 here. What happens if you got a square root of 2x times the square root of 2x, if you multiply it, you can see that you've got a pairing here. And then you've got another pairing. So you got a 2 coming out and an x coming out. So really, we end up with the square root of 10x all over 4x when I multiply those together. Some people think, oh yeah, the square root of 2x times the square root of 2x, because I've got 2 of them here. You know, you can see right away, you got two x's, so you just pull out a 2x. So you could think of that too. Got a pairing of 2 x's, so I can pull the 2x out. So I think we'll leave the cube roots here for the next video here.